So this looks like siltstone. So if you come behind the actual car park of the Wirrawilla walks, you can see there's a lot of this rock in cages. So this is local siltstone, mudstones. Looks like it's heavily indurated with iron oxide, probably metamorphosed as well. If you keep walking, go past this dead bracken, more native plants. Looks like Cassinia. I don't know what species that is. So you can actually just check out the local geology. So obviously what we have here, okay, it feels like a siltstone. And here we have another piece of siltstone. Obviously it's fairly hard. And if skull. So this has probably been excavated for the actual car park. So we do have a lot of material that we can find. It gives us an indication of what it is. This looks like mudstone, doesn't have any cleavage to it. It looks massive, and I don't see any fossils in the actual material. It looks a little bit crystalline, so it's probably a metasedimentary rock. So we can see up there, you can see some of the actual formation. Obviously it's too steep, you can't get close enough. So yeah, so this stuff is quite fresh here. So obviously when it's fresh, so when it's fresh it's a dark colour. Probably an indication that it was an anaerobic environment. Or it could be just a feature of the metamorphic process. And we do have a rind of, looks like iron oxides that coat the actual material, indicating that this has been weathering for quite a long time. It's about 5 millimeters thick. Obviously massive, no fossils, so there's probably no fossils in this type of material. Okay, so this one's been fractured and the iron oxide's actually percolated through. So the iron probably comes out of the actual material, because I don't see any other type of rock that would actually have iron oxides. So this probably has a lot of, probably has quite a lot of feldspars and micas in the actual material. So it could, where would this material have come from? So I'm not too sure on the formation. This could be the Humo Vale formation, about 380 million years in the Silurian. That's just a guess. So the material would probably come from the west, the existing Ordovician material, which is pretty much mudstones, siltstones, which is clays, which has a lot of iron, and also metavolcanics from the Cambrian would have been eroding at the time. So they would have actually contained a lot of feldspars, hornblends, amphiboles. So it would have had quite a lot of iron in the material. So obviously this rock is massive and it's fairly well weathered. And there's no indications of any type of sedimentary facies, and there's no cross bedding. I don't see any ripple currents, anything like that. So this is probably just like a turbidite. I don't see any boomer sequences. And this is, because you can't really see the actual formation up close, it's a bit hard to tell what it is. I'm just going to say this is a turbidite sequence that's pretty dominant around this area. So here we're up close to an actual formation. So the only two things I'm getting is that there is no bedding, so it's just massive formation. Looks like this indications might be bedding, but that's probably just a erosional feature. It looks like it's made out of mudstones. This is probably a massive turbidite sequence. And this is the fresh exposure. This is fairly weathered. So it's not really, this is not really that interesting as formations go. It's pretty much the type of formation you're going to find all over Victoria. So yeah, that's it for this formation. It's probably metamorphosed mudstone, massive formation, probably about 380 to 420 million years ago. Obviously it formed a mountain range during one of the mountain building processes. It's been eroding probably since 380 million years ago. In the Permian there was a glaciation over top, probably removed a lot of the actual mountain range itself, and it's probably been slightly uplifted after the Permian, so there is no deposition within this locality.